All right, good afternoon, guys. So just quick story time. This is the second time I'm doing this practice test video because the first time I didn't have my microphone on. So I spent an hour and a half recording this for you and there was no sound to it at all. So I'm going to try to go through this rather quickly because, well, I've already spent an hour doing it once. So, don't want to do it that long. Okay, so this is a study guide video for the practice 4A test, or for the 4A unit test. This is a practice test video. Remember, before the on the real test, it will be multiple choice. The questions will be similar, not the same, but similar. It's the same mathematical concept tested in each question. And then at the beginning of the test, you will have 5 spiral review questions. So it'll be questions reviewing 7th grade, 8th grade, and material from last semester. You guys are freshmen now. You are responsible for learning, not just learning the current material, but retaining material from last semester. If you can't retain material, you're not going to be successful in class. So you are responsible for knowing how to solve an equation or how to solve a systems of equations. You're responsible for that. I don't know what else to say about that. There's really nothing more to that. So there are going to be 5 spiral review questions based off of what you learned in previous courses. So with that said, let's jump right in. All right, in the first couple of questions, so the first 6 questions, we are dealing with simplifying exponents. And there are 2 main rules when you simplify exponents. The first one is that you want only one of each variable. If you have more than one, then you can somehow combine their exponents. So we only want one of each variable. The second thing we want is we don't want any negative exponents. So no negative exponents. So one of each variable and none of the exponents can be negative. Okay. All right, so number 1, we want to simplify this expression. I have 2 k's, and so what I'm going to do is I'm going to combine them. So I have k to the second and k to the third, and since they're all together, I'm multiplying. When you multiply bases, you add their exponents. So k to the second and k to the third is k to the fifth. M to the fourth is going to just be left alone. There's no other m. We can't combine it. We have one of each variable, no negative exponents. This is simplified. All right, number 2. All right, so I'm going to keep going through the same thing. We're looking for one of each variable, no negative exponents. We also don't want something that can be easily simplified like this fraction. 36 over 4. Well, we can divide that, so let's go ahead and do that. That would be simplifying it. So 36 divided by 4 is 9. And let's move on to the k values. We have k to the 8th over k to the 3rd. When you divide bases, you subtract the exponents. So 8 minus 3 is 5, so this is k to the 5th. And we're going to do the same thing with the m's. When you divide bases, you subtract exponents. So 5 over 2 minus 1 over 2 is going to be 4 over 2. Remember, when you subtract fractions, you leave the denominator alone. You only subtract the numerators. You're left with 4 over 2. 4 divided by 2 is 2. So this is going to be m to the second. Again, we have one of each variable, no negative exponents, and we simplified the fraction. Number 3, we want to simplify mn to the 4th. So something to note is that this negative 4, m doesn't have an exponent at all. It has an exponent of 1. This negative 4 only goes with the n. If I wanted that negative 4 to be with the m and n, it would have been written like this. It would have had parentheses with negative 4 on the outside. This is not the same thing as this. Here, the negative 4, the exponent is only with n. Here, the exponent is applied to both m and n. Okay, so remember, we don't want any negative exponents. So how would you make this exponent positive? Well, n to the negative 4 is equal to 1 over n to the positive 4. You use the reciprocal of that exponent. So instead of n to the negative 4, we have 1 over n to the positive 4. All right, so we still have this m. So it's m times n to the negative 4. So we're doing m times this. And it's just like doing m over 1. When we multiply, we're going to multiply the numerators, then multiply the denominators. 1 times m is m. N to the 4th times 1 is n to the 4th. And just because I've seen this a couple of times, if you have just one number times a fraction, like you have 2 times 1/2, you multiply your single whole number times just the numerator. You don't multiply it by the numerator and denominator because it cancels itself out. If you multiply the numerator and the denominator and then you simplify your fraction, then you've canceled out what you've multiplied by. So you only multiply, if you have a whole number that's not got a fraction, treat it as though it's over 1, multiply the numerators, and leave the denominators alone. All right, number 4. Okay, so looking at this, I have a, we're going to work on just this first. We're going to work on the set of parentheses first. So I have an exponent of 3 on the outside of parentheses. It's going to be applied to both factors in parentheses. So it's applied to both factors. That is the power of a, power of a product. Yeah. I always switch up power of a product and product of a power. Like, I know the two rules, but just talking about it trips me up. But this is power of a product. So I'm taking the power of both factors, or this power is applied to both factors in this multiplication product. Okay, so I've got k to the second to the third. So what happens is I multiply both of my exponents by 3. So k to the second to the third is k to the 6th. M to the 8th to the third, I'm multiplying it m to the 24th. And I've taken care of this piece. Now let's take care of this piece. I have these two things times k to the negative 3 and n to the 0th power. So a few different ways you could go with, you could start working this. As long as you're following exponent rules, it doesn't really matter which exponent rule you follow first. You could take care of the negative and use the reciprocal. Or you could do what I'm about to do and go ahead and, since these are multiplying, add your exponents. So what is 6 plus negative 3? Well, 6 plus negative 3 is the same thing as 6 minus 3, which 6 minus 3 is 3, so we'll have k to the third. If you had done the reciprocal of this and then divided them, you would have had to subtract the exponents and you would have ended up with 3 anyway, so you should be okay. I'm going to bring this m to the 24th down, and then I have n to the 0. Well, anything to the 0th power is 1. So this is the same thing as 1. Now, that 0th power, again, only applies to the n. So only n is equal to 1, not the entire problem. If I wanted the entire problem to be equal to 1, I would have put parentheses around the entire problem and had everything in parentheses to the 0th power. So it's just the n. So n to the 0 is equal to 1. So I'm multiplying 1 times this whole thing, which doesn't do anything. It stays the same. So we're going to leave it here. You could put times 1 at the end if you'd like, but something times 1 is itself, so we don't need to. Okay. Number 5. So when we go to simplify this, again, the 8 this is power of a quotient, so kind of the same concept as number 4. The 8 is applied to everything in parentheses, so this is k to the 8 over m to the 8 times m to the 5th. So you can treat this as m to the 5th over 1 and multiply your numerators and get k to the 8th times m to the 5th over, and then multiply your denominators, get m to the 8th. Okay, so remember, you only want one of each variable. Right here I have 2 m's. So I can do, what I would do next is I would subtract my exponents because we're dividing. So here, there are two different ways you can think of this. You can subtract 5 minus 8, get m to the negative 3, do your reciprocal, and put it on the bottom of the fraction to get m to the positive 3. Or well, let me write that out. So that would look like this. This would be 5 minus 8, which would give you negative 3. You'd have k to the 8, m to the negative 3. To make that positive, it would be k to the 8 over m to the 3. Or if your brain works differently, because mine works differently, and this is how my brain works, I can subtract 8 minus 5 is 3. Now, since I have more m's on the bottom, I have 8 m's on the bottom and 5 on the top. Since I have more on the bottom, my leftovers should be on the bottom. So 8 minus 5 is 3, and those 3 should be left on the bottom of my fraction. Again, it's same concept. I'm doing the same math, but I'm thinking of it differently. That's the beauty of math, is that there are a few different ways you can approach a problem and still come out with the same answer as long as what you're doing is mathematically legal. It's just a different way of thinking about it. So either way, this is what you should come up with when you simplify. All right, number 6. Find the volume of a cube with a side length of 5n squared. So if I have a cube, I'm going to draw mine out first, just so you can see it. If you're one of those people that need to draw a picture, draw your picture. Don't feel like don't feel ashamed of drawing a picture. Some people, that's how they see things. I do that all the time. My husband and I, my husband builds me stuff. He built me some shelves for my laundry baskets over the weekend. He had to sketch it out before he started building it. If he didn't, it probably would have looked jacked up, and I probably would have been mad at him when he tried to put it in my house. So draw your picture. It's fine. Okay, so we want the volume of the cube. The cube has a side length of 5n squared. So remember, volume is found by multiplying your length times your width times your height. Now, when we're doing volume of a cube, though, we know that a cube has a length, a width, and a height, or length, width, height. All of those are the same. It's a cube, so every edge is the same. It's a square, it's a three-dimensional square. So every edge length is the same, or every side length is the same. So I'm doing the side length times the side length times the side length, since they're all the same. So that's the same thing as the side to the third power, or the side cubed. In fact, that's why we call it a cube. Or maybe that's why we call this cubing. I'm not sure, one or the other. It's related. Okay, so I have 5n squared cubed, and that would give me my volume. So remember, the exponent of 3 is applied to everything in parentheses. So 5 to the third is 125. N squared to the third, you're going to multiply your exponents and have n to the sixth. And that is your volume. And if we are talking about units, we're going to say it's units cubed. If it were feet, we'd say feet cubed. If it were inches, we'd say inches cubed. All right. Whew. So that's everything on simplifying exponents. I'm going to pause this here. I know it's a short video. This one's only 13 minutes, but I also know y'all kind of appreciate them a little bit more short. So this is the first 6 problems. This is just on simplifying exponents. The next quick video will be on simplifying radicals. So thanks so much for paying attention, and I hope y'all have a good evening.